Hey everyone, hope you're enjoying PyGotham so far. This is my third year at PyGotham, but my first time speaking here. My name's Dane Hillard, and I'm a web application developer. In this talk, you'll learn about how to keep your code safe and modern with the power of semantic searches. My Twitter handle is easyAsPython, which you'll see at the bottom right of this presentation, as well as on my speaker page. Please feel free to keep in touch with me there. As developers, we enjoy a quality bit of automation. Many of us reap a certain satisfaction when we can delegate a repetitive task to a program instead of doing it ourselves. Sometimes we do this to a fault. We think we'll have so much free time after we've automated something, when in reality we fill that space developing that very automation that we hope to benefit from. The best kind of automation ultimately narrows our focus and directs our attention toward problems that haven't been solved yet, so that we can spend our time where our input is most needed. During that process, noisy feedback will only obfuscate important issues with things we can't or won't or don't even know how to fix. Especially when an issue has a known fix that can be automated, we should lean toward letting the computer do that, especially when we can build enough confidence to do so. And as we develop software, two major classes of feedback arise. We can use static analysis to glean insights about the way code is shaped and connected without executing that code. When static analysis is fast enough, we can run it continuously as we're writing code. IDEs can give feedback about that analysis in line with the code in real time. Even when you don't use an IDE, many static analysis tools are command line interfaces under the hood, so that value is just one or two commands away. Runtime feedback comes to us during execution of a program and tells us more about what's happening in practice rather than in theory. In the worst cases, runtime feedback is unhandled exceptions whose stack traces we need to interpret, but this can also include things like observability metrics and situation-dependent deprecation warnings. Failing unit tests are also a type of runtime feedback. They tell us that the behavior of the code while it was running did not meet our expectations. The best feedback is also given at early, frequent intervals. The tighter we make our feedback, the earlier we can correct our trajectory. Late feedback is painful feedback. This is a driving force for test-driven development, and it's the core of the shift-left movement more generally. As we seek more sophistication in our own software development experiences, we should favor real-time feedback first, frequent feedback next, and slow, infrequent feedback only as a last resort to catch things that fall through the cracks. So even once we've got syntactically correct Python code with proper imports, passing unit tests, and so on, we shouldn't necessarily stop there. We know that some constructs can be misleading or even dangerous. We know that some constructs will be deprecated in ways that aren't called out with deprecation warnings. We actually know a lot. And we should get as much of it out of our heads and into our ecosystem as possible so others can benefit from it. This can also reduce interpersonal strain. Better that a computer point out my mistake for the 19th time than a human. And organizations rarely use a single language or framework to build products. When a codebase contains Django, FastAPI, jQuery, Vue, React, you'll likely end up with a patchwork of code quality tools to check linting, formatting, security, and so on. This may work all right for the built-in checks that all these tools come with, but organization-specific checks with that tacit knowledge can be tedious or even impossible to configure within the confines of these tools. Some constructs just aren't searchable with a regular expression, for example, especially if they span lines or depend on knowledge of the code structure, especially in cases where the construct spans frameworks and languages. So what exactly do we want out of all of this? We need tools that we can configure and extend, ideally that work across many languages and that have knowledge about how those languages actually work. And hopefully you're getting the sense by now that we want that feedback as early as possible, ideally as we're writing our code. So the short of this is that semantic querying tools aid us in building and answering more sophisticated questions about our code base. This power reduces bugs, improves adherence to conventions, speeds up activities like framework version migrations, and more. You can think of these like highly personalized linters. Semantic querying helps us answer questions like, where does this function get used, considering any of the ways that it might be imported and referenced? Where do we use pre-formatted strings in our logs, in any of the ways that you might format a Python string? Which of our Django database tables might lose records when we delete a record from table X? These are the kinds of questions that we often ask ourselves during development, but that we rarely ask the computer to tell us. Tools have really started to make this possible. Sengrep, which I have to assume is short for semantic grep, is one such tool in this space. Sengrep provides a command line interface for quick searches and running configured queries or rules. It also provides a rules engine configured with YAML for building complex queries that are aware of the structure of the code. These rules can be composed of small individual queries, filtered to exclude other queries, and even nested within one another. Queries can also store bits of matching code so that they can be displayed in a message to the developer or to offer an automated fix suggestion. It's actually intensely powerful. In addition to the grep-like command line syntax and the configurable YAML rules, Sengrep also provides a pre-built community-driven rule set that can be used in your code quality pipelines to sort of immediately take advantage of things that others have already defined as important. To give you a sense of the way Sengrep thinks about code, let's look at a few examples. This first example finds all the places that the baz function in the foo.bar module is called, regardless of how it's imported and referenced in a module. The foo.bar.baz in the pattern represents the fully qualified path to the baz function, and Sengrep knows the variety of ways this might appear in the code. This ellipsis indicates that Sengrep should find any instances regardless of the arguments passed. The second example finds only calls where a quux keyword argument with any value is among the arguments passed to the call, storing the found quux value in a meta variable for later use. The third example will match calls to any function from the foo.bar module, storing the name of the found function for later use. These all work even if the call is formatted to span several lines. This example shows how rules can be configured with Sengrep's YAML schema. The rule configured here encourages use of log interpolation for better performance and aggregation. The configuration specifies an ID for the rule to distinguish it from other ones in the output, that Sengrep should only check that rule on Python files, an actionable message for the user when any matching code is found, a severity of warning as opposed to error, and a set of patterns that look for any Python method calls where the method is one of the logging levels and one of the arguments passed to the call is a formatted string. I ran this configuration on an example file, and Sengrep found a formatted string in one of my logs. You can see that it printed each matching file and line, and it bolds the offending construct, which in this case is the full line, but can also be a partial line, depending on the pattern that you specify. Here's another example rule I pulled from the community rule set for Django. This rule ensures that if you're only using the record count of a query, that you leave that job to the database to avoid unnecessary memory usage and computation at the Python layer. You can see that it also makes use of this pattern either construct with a list of patterns, which allows you to search for any of those patterns as a match. So another big plus for Sengrep is how tightly it integrates with tooling at nearly every step of the development workflow. It plays well with IDEs, so you can get real-time feedback for the currently open file. It plays well with pre-commit, so you can get feedback for all changed files, which is also useful for incremental adoption of new rules. It also plays well with GitHub Actions and other CI or command line scripting tools, so that you can get insights across the entire repository on a scheduled or ad hoc basis. This is powerful in building confidence in code changes at each step along the way to delivery. So with its semantic search capabilities, configuration as code, and tight integration with other tools as well as its extensibility, Sengrep is powerful and useful and mostly a joy to use. Its place as a generalized linting and security tool might provide a lot of value to you and your organization. I'm not affiliated with Sengrep, and this is not an advertisement for it specifically. It sort of is. But these The key takeaway here is that tools like Sengrep are out there waiting for you to use. Enterprise has eaten this space in the past, but open source tooling is becoming more available all the time. Take stock of what's around you, read the docs, and figure out what's best for your ecosystem. I leave you with a reiteration of a few points. Provide actionable feedback. Warnings that can't be fixed will lead to signal fatigue and obfuscate real issues. Suggest a specific fix when possible. This increases actionability and narrows focus to the less obvious issues. And shift left. Verify code using analysis in later parts of your development workflow, but aim to shift this feedback as early as possible for maximal productivity. I enjoyed the opportunity to share these ideas with you today. I'm Dane Hillard. I wrote Practices of the Python Pro, and I'm writing Publishing Python Packages. Enjoy the rest of the conference.